To find the area of a rectangle, we always need to multiply the width by the length, or the length by the width. So, for example, rectangle 1 is 5 centimetres by 2 centimetres. 5 times 2 equals 10. And because the units are centimetres, the answer will be centimetre squared, because it is the area. For rectangle 2, 8 times 3 is 24. Because the units are metres, the answer will be metres squared. And finally, rectangle 3, 10 times 5 is 50. And because it's kilometres, my answer would be 50 kilometres squared. Compound shapes are just shapes made up from other shapes. And to find the area of these, we use what we have just done on finding the area of rectangles. So our first step is to split the shape up into rectangles. And I can do this one of two ways. I could split the shape up this way, or I can split the shape up this way. And it shouldn't make any difference. I should always come out with the same answer. So I'm going to cut this shape this way. Shape 1 and shape 2. To find the area of shape 1, I need to do 2 times 2, which is 4. It's in centimetres, so it would be 4 centimetres squared. To find the area of shape 2, I would need to do 5 times 3. 5 times 3 equals 15 centimetres squared. So, to find the area of the whole shape, I just need to add these together. So the area of that compound shape would be 19 centimetres squared. Our second example is a little bit trickier. This time I need to split it up into 3 shapes. I could split it up along here and along here, or I could split it up along here. Doesn't make any difference. So I'm going to split my shape up this way, creating 3 new shapes. Shape 1, 4 times 4. Shape 2 is 4 times 4. Shape 3 is a bit trickier because I haven't got the length at the bottom. So I need to look at the information that I have got. I should be able to see that if I add 4, 4 and 4, this will give me the length along the bottom. So the length along the bottom is 4, add 4, add 4, which is 12 centimetres. To get this little bit, the width of this new rectangle, I need to have a look. If this is 8 centimetres and I knew that this bit here was 4, this means this part here must be 4 as well. So the area of shape 3 would be 4 times 12. I now need to work each of those out. And each one is centimetres squared, because each one is the area. Then, to find the total area of this compound shape, I need to add those together. 16 add 16 is 32, add the 8 is 40, add the 40 is 80 centimetres squared. These compound shapes are a little bit trickier, but I use the same method. I split them up into rectangles and number my rectangles. To find rectangle 1, I would do the 3 times 12. That's my 12 and my 3. To find rectangle 2 is a little bit harder because I know this long length is 12, but I need to know just that middle bit. So, because I know that I've got the 3 and the 3, and I know the whole bit is 12, this must make this bit 6, because 3 add 6 add 3 is 12. And because it's 6 one side, I know it's 6 the other. Then, to get this part here, if I know that this long side is 15 and this bit is 10, then this bit here must be 5. So for rectangle 2, I've got 5 times 6. For rectangle 3, I've got the 10 and the 3, which makes 30. 5 times 6 is 30, and 3 times 12 is 36. Again, this time they are meters, so the answer for each one would be meters squared. And then to find the total area of the compound shape, I would add these together. Sometimes we get a question like this, and we are asked to find the shaded area. To do this, first of all, I ignore the white rectangle in the middle and just find the area of the large rectangle, which would be 10 times 12, which is 120 meters squared. Now I would find the area of the small rectangle inside, which is 7 times 2, which is 14 meters square. Therefore, the area of the shaded, the grey part, would be 120, take away that 14, 106 meters squared. Finding the area of a triangle is quite easy. You just need to remember that a triangle is half of a rectangle. So, we find the area as if it was a rectangle and then divide it by 2. But we don't call them lengths and widths. We call them base and height. So the base of the triangle is the bit that it sat on, and the height is from that base to the top. It's not the length of the side. Do not get confused. So for example, if we look here at this question, we can see the base is 5 centimetres, and it would be very easy to multiply this by the 6. However, the 6 centimetre is the length of the side. It is the height that I need to multiply by, so the 7. So to find the area of this triangle, I would do 5 times 7 divided by 2. 35 divided by 2 would give me 17.5 centimetres squared, because it's still area. Really, really important. The base times the height and then divide it by 2. Have a go at finding the area of these triangles, remembering that you need to do base times height divided by 2. If you pause the video and then press play, the answers are on the next screen. Here are the answers. How did you get on? The area of a parallelogram sounds a lot harder than it is. You need to remember a parallelogram is just a rectangle that has fallen over. So we treat it like we did with the finding the area of the triangle, but without dividing it by 2. So instead of length and width, as we used for rectangle, we use base times height. Really, really important. Sometimes the height is shown inside the parallelogram, as it is here. Sometimes it is shown outside of the parallelogram, like in question 2. So, if we have a look at question 1, the base is 4 times the height, which is 5, so the answer would be 20 meters squared. For question 2, our base is 10, our height is 3. This time they're centimetres, so the answer would be 30 centimetres squared. The area of a trapezium is a bit trickier. The important thing is to recognise where the parallel lines are. Remembering, parallel lines are like train tracks. They're the two lines that stay the same distance away from each other. They don't get any closer or any further away from each other. The parallel lines are A and B. So we can see on the shape below that the parallel lines are here and here. So to find the area of a trapezium, the formula is half times A plus B times the height. So let's look at this example. My A and my B, the first thing I need to do, thinking about BIDMAS, is the part in brackets. So I need to add the A and B together. So A is 2 and B is 10. So I've now got my area equals half of 2 plus 10 times 6. So we know that 2 plus 10 is 12. So I've now got half times 12 times 6. Well, half times 12 is 6, times 6 gives me my answer of 36, and it's centimetres squared because it's another area. This is much trickier, but you never have to remember this equation because it's in the front of your exam paper. Let's have a look at this example together. So remember, we need to do half A plus B times the height. So half times A is 8 and B is 10, which is 18, times the height, which is 6. Half times 18 is 9. 9 times 6 equals 54, and it's centimetres squared. Now we're getting on to the really tricky stuff, the area of a circle. To be able to work out the area of the circle, you need to know the radius, and the radius is always the midpoint of the circle to the edge. So once you know your radius, we need to do pi times the radius squared, pi r squared. Now, if you've got a scientific calculator, there will be a pi sign on it. But if you haven't, you need to use 3.14 as pi. So, remembering BIDMAS again, it's really important that you do the radius squared first and then times it by pi, because it's not pi times radius and then square the whole thing. So let's look at some examples. Right, so the area of our circles are pi times radius squared. So for example 1, we will have pi times 14 squared. 14 squared is 196, and if I've got a scientific calculator, I can do this times pi, which would come out as 615.75 to 2 decimal places. Because the units are metres and its area, it would be metres squared. Having a look at example 2, this time my radius is 3. So the first thing I need to do is 3 squared. 3 times 3 is 9. So on my calculator, I need to do pi times 9. Pi times 9 comes out as 28.27 to 2 decimal places and centimetres squared, because it is the area of a circle.